Welcome to the exam review of the Indian Actuarial Professions CT1 paper for November 2015. I'm John Lee, a tutor from ACTED, the actuarial education company, which provides study materials and coaching on behalf of the UK and Indian actuarial professions. In this video, we'll give a brief overview of each of the questions on this paper. If you find this video helpful, then you may be interested in the other online coaching, revision materials and study support that we offer, details of which can be found at the end of this video. So this question tests interest rates from chapters 2 and 3. In part 1, we've got two options: a cash payment of 30% below the recommended retail price and 6 months credit at 25% below the recommended retail price. And we have to solve them to get the annual rate of discount. Well, presumably these two terms are equal, and so we're going to have to equate them to find the rate. Well, let's use R to stand for the recommended retail price. Then the cash payment will be 30% below that, which is 0.7R, and that'll be obviously at time 0. And the 6 months credit is 25% below that, so that's 0.75R, and that's in 6 months' time, so half a year. We need to solve the equation of value. The present value of the cash payment is 0.7R, because that's at time 0, and the present value of the 6 months credit is 0.75R times V to the half, because it's in half a year. Now, just to highlight, we want the annual rate of discount, not interest. So first of all, we'll rearrange this and solve this for V, and then recall that D is 1 minus V, so we get a result of about 12.9%. Now for part 2, we have to obtain other rates, D12, I2, and delta. Probably the easiest way of doing this is to first obtain the annual effective interest rate. So I is D over 1 minus D, which gives us a rate of about 14.8%. Now we've got this, it's no bother to obtain the other rates. D12 is 0.13720, I2 is 0.14286, and delta is 0.13799. This question tests variable force of interest from Chapter 3 of the notes, but it doesn't test payment streams from Chapter 5. In the first part of the question, we're asked to obtain the present value of 1 unit due at time t. This will be straightforward. All we have to do is take our payment of 1 and multiply it by a discount factor, which for a variable force of interest will be minus, between the times of 0 and t, of our force of interest, which we're told is a e to the minus bt. So I'm going to do a e to the minus bu, because we shouldn't have t both as the variable and the limit. Integrating this gives the following. Substituting in our limits of t and 0 give this, and then taking out a common factor of a over b gives the following, which you'll notice is not actually equal to the examiner's required result. That's because they've made a mistake. For part 2 of the question, we're told some information about the force of interest, and then asked to find the present value of 4 annual payments of 1,000, with the first made at time 1. So first of all, we're going to use the given information to find the values of A and B. Okay, we're told at time 0, the force of interest is equal to 0.01. Using our formula, A e to the minus bt, that will equal A. So we've got the value of A. We're told 10 years later, the force of interest has fallen by 50%. So that'll be 0.005. And that will equal A e to the minus 10b. Okay, well, substituting our value of A from the first equation into the second gives e to the minus 10b is 0.5, and then we can solve this to get a value for B of a rather awkward 0.0693147. Okay, now we need to get the present value of these 4 annual payments. Well, taking out a common factor of 1,000, we've got a payment at time 1, and from part 1 we can use our discount factor, and then we've got a payment at time 2, payment at time 3, and a payment at time 4. So we can substitute these values of t in and the a and b, but let's be blunt, this is going to take quite a bit of time. A lot of work will give you an answer of 39,108 if you kept all the accuracy on your calculator, or about 39,110 if not. For the final part of the question, we're asked what constant force of interest gives the same present value as part 2. So if we use a constant force of interest of delta, then the present value of those payments will be 1,000 times e to the minus delta plus e to the minus 2 delta, and so on. We equate that to our 39,000 figure and then solve for delta. However, the examiners only give us 1 mark. Frankly, this will take too long, though if you've got a Casio calculator, you can make use of the table mode to solve this more quickly. This will give you an answer of delta is 0.0090. This question tests forward contracts from Chapter 13 of the notes, though it's rather a confusing question, and so a timeline will be very helpful. We're told that 9 months ago, John entered into a 1-year forward contract, and the forward price was 1,000. However, we're not told the share price at the time when the contract was made, but we are told the bond yield at the start of the contract was 8.75%. It doesn't specify, but we'll assume that's an effective rate. We're now told that the yield has decreased, and we want to calculate the new price of shares to neutralize the effect of the change in the market condition. Okay, this is a little bit confusing, but what it seems to be saying is that the forward price is still 1,000 for the current share price at this new rate of interest. Well, let's use our equation for the forward prices from Chapter 13 of the notes to get what the share prices are, and then we can calculate the increase in the price of those shares. Now, there's no dividends made, so the formula we'll be using is the forward price is the initial share price accumulated up. Since we've got an effective rate, that will be 1 plus I to the t. So from time 0, we'll have 1,000 is equal to S0 times our 1.0875 to the power of 1. Solving this gives our initial share price to be 919.54. Using the formula at time 9 months gives us 1,000 is equal to the share price at 9 months times our 1.0780, and there's 3 months left. Solving this gives a share price of 981.40. So we can see there's an increase of 61.86. Question 4 tests project appraisal from Chapter 10 of the notes, and we're asked to calculate the net present value. As always, the best thing to do here is to start with a cash flow diagram. We're told there's a continuous investment of 10 per year for the first 2 years. Then we're told we receive payments at the end of each year, with the first payment at the end of year 3, so that's time 3, which will be 8. And then it goes down by 0.5 each time, so 7.5, 7, and so on, and we carry on until we get to 3. Once we get there, we're told that the annual reduction will be 1 a year. So we'll get 2, then 1, and then nothing. So the project will end. Okay, we need to get the net present value, so we're going to split this up into 3 parts. First of all, we'll do the 2-year continuous level annuity, which will be minus 10, A bar 2. And we can see we've got a simple decreasing annuity from time 3 to time 13, so 11 payments in total, but it's deferred. So we're going to use V squared, and then because it's going down by 0.5 each time, it'll be minus 0.5 of an increasing annuity, and as we said, it's 11 payments. And so that means we must have a level annuity of 8.5 each time. Then all we've got are the 2 final payments of 2 due at time 14 and 1 at time 15. We just need to solve this at 10%. Given the timing issues, it'll probably be quickest to use the tables, in which case you'll get an answer of about 14.59. Question 5 tests stochastic interest rate models from Chapter 15 of the notes. And we're told we have a varying interest rate model, and we're given an initial deposit of 2,400, and we're told after 5 years we get a mean of 3,600 and a standard deviation of 50. We'll recall the accumulation of 1 unit under the varying model is 1 plus j to the n, in this case 1 plus j to the 5. So the accumulation of 2,400 will be 2,400 times that. And that gives us 3,600. Okay, well you can solve that to get what your j is, the average interest rate in each year, which would be 0.08447. Okay, now we need the standard deviation. Well, we've got a formula for the variance, which for 1 unit was 1 plus j squared plus s squared, which was the variance in each year, all to the power of n, so in this case 5. Take away our mean, 1 plus j to the 5 all squared, so to the 10. Okay, now that's for 1 unit. So for 2,400, since it's variance, we'll need to square that. And that will give us a variance of 50 squared because we're told the standard deviation was 50. Okay, well, we substitute our j into the formula and then rearrange to get s squared, which will give you an s squared of 0.000045369. Okay, now the question doesn't ask for the j and s squared, it asks for alpha and lambda because we're told we've got a gamma distribution. Okay, well, flipping to page 12 of the tables, we see that the mean of a gamma is alpha over lambda. So we've got alpha over lambda is our j, and the variance of a gamma is alpha over lambda squared. So we need to solve these equations simultaneously. The easiest way is to divide the first one by the second one, and that will give you lambda straight away to be 1861.844 if you kept all the accuracy, and then substitute that back in the first equation to give you alpha of 157.273. Question 6 tests spot rates, par yields, and the coupon bias from chapter 14 of the notes, and is a fairly straightforward question. First of all, we're given a formula for the n-year spot rate, and we're asked to find the 3-year par yield. So using the formula, we can get the 1, 2, and 3-year spot rates, and then we're ready to find the par yield. Now, the 3-year par yield is the annual coupon rate, which we'll call C, on a bond that's redeemed at par and priced at par. You could use 1 to give your C as a decimal. I've used 100, so my C will give a percentage. So we need to solve the equation of value. The present value of the outgo is 100. Present value of the income is the first coupon payment, and we'll need to discount that at our 1-year spot rate. Then the second coupon will discount at the 2-year spot rate, and the redemption of 100 and the coupon payment will discount at the 3-year spot rate. Solving that gives you a C of 5.235. Now we're working with a £100 nominal, so that's 5.235%. Okay, we're now ready to do part 2, which is obtain the coupon bias. Now this is a very brief note in the core reading that says the coupon bias is the difference between the n-year par yield and the n-year spot rate. So we've got the 3-year par yield of 5.235% and a 3-year spot rate of 5.1%. So the difference between those is 0.135%. So that's our coupon bias. Question 7. Test loans from chapter 9 of the notes. And this question's fairly demanding. First of all, we're told that Mr. Patel is repaying a loan over 2 years, paid monthly in arrears, of $360,000 per month. But he's going to do this by investing an amount X in a bank at 6% interest. So how do we find X? Well, we simply solve an equation of value. The present value of the money in the bank, which is X, should equal the present value of the payments he makes. It's $360,000 a month, so 12 times 360,000 a year, and then we have an annuity, paid 12 times a year for 2 years. And we're calculating this at 6%. Given that it's only 2 marks, we're going to have to use the tables, and if you do that, you will get an answer of 8135807. If you calculated it accurately, then the final 3 figures would be 772. Okay, let's take a look at part 2. We're told everything remains the same for the first year, but at the beginning of the second year, the interest rate will now drop to 4%, convertible quarterly. And then what's more, the rent will increase to $460,000. And we're going to show that we run out of money at the end of October 2011. The way we deal with these kind of questions is to calculate the loan outstanding every time a change occurs. So the first thing we need to do is calculate the loan outstanding at the end of the first year when the bank rate changed. So we could either accumulate this, or equivalently we can do the present value of the future payments, which using tables gives us the following. Okay, the interest rate has now swapped to 4% convertible quarterly, which tells us that's 1% per quarter. And the next change that occurs is 3 months later. Now we can't use the prospective method here, the present value of the future payments, because they're now no longer equal, as the savings will not pay off the loan. So we're going to have to do the accumulated value. So the loan outstanding 3 months later will be the loan outstanding at the beginning of the year, plus 3 months worth of interest, i.e. a quarter of a year's worth of interest, which is 1%. We now need to take off the accumulated value of all the payments we make during those 3 months. which gives us an answer of 3144658. Full accuracy would have given 640 at the end. Okay, so we're now up to April, and we've got the new monthly payments of 460,000, and we need to show that we run out of money on October 2011. The easiest way of doing this is work out how much money we have at the end of the previous month, i.e. at the end of September 2011, which is in 6 months' time, and then show that this is less than the rental payment of 460,000. So the loan outstanding after a further 6 months, so end of September 2011, will be the loan outstanding that we had at April. We've got 6 months worth of interest, which is half a year or 2 quarters, so that's 1% for 2 quarters. Then we're going to take away our rental payments, which are now 460,000, and that's for half a year. This gives us a value of 424,840, or if you kept full accuracy, 821. Since this is less than the monthly payment of 460,000, it means we won't be able to afford the next payment. And for the final part of this question, we're asked how much money we should have put in the account on the 1st of April so we could just cover the remaining payments. Well, all we have to do is work out the present value of those future payments on the 1st of April. So loan outstanding on the 1st of April would have been our 460,000 a month, and from the 1st of April to the end of the term is 9 months, and calculating this gives us 4,072,058. We had 3,144,658, so the difference between those is 927,400. If you kept complete accuracy, it would have been 418. Question 8 tests fund performance from Chapter 10 of the notes. And so is our second question from Chapter 10 so far. We're going to be working with the time-weighted rate of return, the money-weighted rate of return, and the linked internal rate of return. In fact, everything. However, the mark's quite tight. So first things first is draw ourselves a cash flow diagram. It's for 2 years, and in April in the first year, there's a cash inflow of 40. At the end of the first year, there's a cash outflow of 50. Okay, we're given some fund balances of 460 at the beginning. Have to be a little bit careful here. We're given 500 just before that cash flow, but told it's 550 just after that cash flow. For some reason we're giving another balance of 600 for the 1st of July 2016, and we're not told what our final fund balance is. Now we are told that the time-weighted rate of return over the 2 years is 20% per annum, and we get that by multiplying our accumulation factors between the cash flows. Here's our first period, and we finish with 500, and we started with 460. Here's our second period. Now we're told the balance was 550 after 50 was taken out, and so that means it must have been 600 before that, and we started with 500 plus the cash flow 40, so 540. And then for our final period, we finish with X, and we started with 550. That'll be the time-weighted rate of return is 20% per annum, so for 2 years, 1.20 squared. Rearranging that gives X to be 655.776. Now we've got that, we're asked to calculate the money-weighted rate of return. The money-weighted return is obtained by accumulating the cash flows. So our initial fund value was 460, that's accumulated 2 years. We had a cash flow of 40 in April of the first year, so that leaves us 1 year and 9 months left, and then a cash outflow at the end of the first year, so that needs to be accumulated 1 year, and that should give us our final fund value, which we just calculated in part 1 as 655.776. Okay, you're going to have to solve this using trial and error. I used the table mode on my Casio, and got an answer of 19.9% to 3 significant figures. But frankly, that will be very tight on time. For the third part, we have to calculate the annual effective linked rate of return using subintervals of a year. What we have to do is calculate the internal rate of return, or equivalently the money-weighted rate of return for each subinterval, and then link them together. So our first subinterval is that first year, and we started with 460, accumulate that to the end, 1 year, and then we had cash inflow of 40, accumulate that to the end, and that should give the money that we had at the end of that period. Well, again, remember it's 550 after we've taken out 50, so before that it's 600. You could call this x, then this is x squared and solve a quadratic, in which case you'll get I1 to be about 20.46%. We now need to calculate the return during the second subinterval, which is here, and we start with 550 and we accumulate that to the end of the subinterval, and there's no cash flows in between, so we just finish with our final payment of 655.776. So that'll give you an I2 of 19.232% per annum. Okay, we now need to link those two payments together. So if I is the linked internal rate of return, and that's for 2 years, and we'll do our 20% for the first year and our 19% for the second year, and that will give us an average value of about 19.8%. The final two parts are a little bit of bookwork. Part 4 has been asked a couple of times before. The linked internal rate of return will be the same as the time-weighted rate of return if the cash flows coincide with the subintervals. And which is a better measure of fund performance? So here's where we talk about the fact that the money-weighted rate of return involves the cash flows, which are not under the control of the fund manager, and so time-weighted rate of return is preferred. Question 9 tests project appraisal from Chapter 10 of the notes, which makes it now the third question on this chapter, and a total of 26 marks on this chapter. Clearly this examiner's favourite. Part 1 is a bookwork question, where we simply have to explain what the DPP is. Part 2a is to calculate the DPP at a rate of interest of 7%. As mentioned before, a cash flow diagram is always helpful here. We're working in thousands, so we initially pay out 800 at time 0, another 50 at time 1, and then it's a payment of 100 per year paid continuously for 20 years, but starting at time 2. Now, the discounted payback period will be the time when we break even. So you can work with accumulated values, or you can work with present values. Doesn't make any difference. I'm going to work with present values, and we can see that since the first 2 years are outgoes, we're going to break even somewhere between 2 and 22 years. So net present value is minus 800, minus 50 in 1 year's time, and then we've got this 100 per year, starting in 2 years' time, and pay continuously. And let's go up to time t. Now when we break even, the net present value will be 0, and it's really no bother to rearrange this equation and solve for t. It's at 7%. That gives t is 15.768. However, don't get caught out. That t is the number of years the annuity has been paid, but the annuity starts at time 2. So the DPP is 17.768 years. And recall, because it's a continuous annuity, we can break even at any time. Okay, now we've done that, we can move on to part B. We break even at 17.768, and we're now told we'll earn interest of 6%, and we need to get the accumulated value. Well, let's just accumulate our 100 per year for however many years are left, to be 22 minus the 17.768, which is 4.232 years. Calculating that at 6% gives an answer of roughly 480. But remember, we're working in thousands, so 480,000 rupees. Okay, part 3 of the question is basically repeat part 2, but this time payments are received annually in arrears. So first things first, let's find the DPP. Our net present value will now be this. Solving this at 7% gives us T is 16.776. But this time the payments are not continuous, but are annually in arrears. And so we can only break even at the next payment, which is times 17. But again, don't get caught out. That's the number of years of annuity. So altogether, that's 19 years from the start. So the DPP is now 19 years. Okay, finding the accumulated value is a little bit awkward, because at time 17, we'll not only break even, we'll actually have a little surplus. And that would be calculated at the 7%. So let's work out what that surplus was at time 19. We can find the net present value of the payments up to time 19 and then accumulate them, or alternatively, we can accumulate the whole lot. I'm going to go with the first option. So the net present value of payments up to time 19 is the following, and then accumulating those values gives the following lump sum. So we're now going to accumulate this lump sum and then the final 3 years of payments. And we'll do this at 6%, which gives us an answer of 344.33. Question 10 tests immunization from Chapter 14 of the notes and makes our second question on Chapter 14 for a total of 18 marks altogether. It's actually extremely generous on marks for a very straightforward question. Part 1 is bookwork explaining what is meant by immunization, and Part 2 we need to work the size of the two zero coupon bonds which ensure that our liabilities are immunized. Okay, let's take a look at our liabilities first of all. So we have payments of 5 million at time 8 and 10 million at time 11. So the present value of those liabilities is 5v8 plus 10v11. Calculating this up, our 8% gives us the following. Now we'll do the same thing for our assets, which is a zero coupon bond repaid at time 6, so we'll call that X, and a zero coupon bond repaid at time 15, which we'll call Y. The present value of our assets will therefore be XV6 plus YV15. The first rule of immunization says our present values will be equal. But we've got two unknowns, X and Y, so we're going to need two equations. So we need to use the second rule of immunization. There are several ways of doing this. We could calculate the DMTs and equate them, calculate the volatilities and equate them, or more easily, just calculate first derivatives and equate those. Now we're differentiating with respect to I and not with respect to V. So V to the 8 is 1 plus I to the minus 8. So we'll times by minus 8, drop the power by 1 goes to minus 9, and so on. And that gives us 63.692. Doing the same thing for our assets gives the following. And again, we're going to equate those. We've now got two equations and two unknowns. We just simply have to solve these using simultaneous equations. Personally, I'd go for elimination by multiplying both equations by minus 6v, then adding them up to give the y of 9.4625, and then the x of 6.3589. Okay, for part 3 of the question, we need to demonstrate that the portfolio is immunized, so we need to use the third of Reddington's conditions. This is that the convexity of the assets is larger than the convexity of the liabilities, or equivalently, the second derivative of the assets is larger than the second derivative of the liabilities. Well, the second derivative of the liabilities, again, this is with respect to I, is the following, which is 652.111, and the second derivative of our assets is the following. Now, if we substitute in our values of x and y that we've calculated, we get the second derivative to be 758.074, which we observe is greater than the second derivative of our liabilities, so it is immunized. Intuitively, this is correct because convexity is a measure of the spread, and we can see that our assets are spread between times 6 and 15, which is larger than the liabilities which are spread between times 8 and 11. Question 11 is another question on repayment loans from Chapter 9 of the notes, which makes our second question for a total of 21 marks, which is the second largest chapter tested on this paper. It's fairly standard stuff, but is a little bit awkward. First of all, we need to calculate the monthly payment. So solving the equation of value, we're told that the loan is 988,000, and that's repaid over 25 years, monthly in arrears, and if I use M for the monthly payment, then our total annual payment is 12M, and we're calculating this at 7% per annum. Given that it's only 2 marks, we're going to have to make use of the tables, and you'll get a value of 6,848 to the nearest rand. For part 2 of the question, we need the loan outstanding immediately after the repayment on the 10th of March 2029. Well, that's 13 years and 8 months into the loan, and the way we calculate the loan outstanding is to do the present value of the future repayments, i.e. the present value of the payments over the remaining 11 years 4 months. Calculating this at 7% gives us a value of 648,575. Part 3 of the question requires the capital to be repaid on the 10th of October, so the capital repaid in just one repayment. The way we do this is we need the loan outstanding after the previous repayment, i.e. the 10th of September 2026. Well, that's 11 years and 2 months into the loan, and again we get the loan outstanding by doing the present value of the remaining payments, i.e. the remaining 13 years and 10 months. Calculating this at 7% gives us 736,121. Now, between this loan outstanding and our next payment, we've got a month's worth of interest. The easiest way to calculate the interest that's accrued is to do I12 over 12. That's the effective monthly rate. For this question, I stored I12 in my calculator, and then I simply reused it on all the parts, as a lot of these annuities are not tabulated, so that would have saved me time. This gives a value of 4,162.14, and that will be the first thing that our repayment pays off. Now in part 1 we calculated the monthly repayments to be 6,848, so that means the capital to be repaid is about 2,686. For the last part of the question, we want the capital and the interest to be repaid over a total of 12 months. The way to do this is to calculate the loan outstanding at the beginning of the period, the loan outstanding at the end of the period, and then subtract the two. Now, since we're told we wish to include the April 2033, we need the loan outstanding after the previous payment, i.e. March 2033. Well, that's 17 years and 8 months into the loan, so the loan outstanding will be the present value of the remaining 7 years and 4 months. Calculating that at 7% gives us 473,728. Now, the loan outstanding after the last payment, the 10th of March 2034, well, that's just a year later, so it gives us 422,108. So the difference between those will be the capital repaid over the year, which is roughly 51,620. Now, how do we get the interest? Well, remember, each month we're paying 6,848. The actual figure is about 0.04 or 0.05 if you use tables. So we're going to have 12 months of those payments, and we're told that we've paid off capital of 51,000. So the difference between the total payments we made and the capital paid off will be the interest, which is roughly 30,557. Again, you might get slight differences depending on what you stored the monthly figure in your calculator as. What do you mean you didn't store it? This will save you time in the exam. Do so. Question 12 tests bonds from Chapter 12 of the notes. And it's a very straightforward question for 15 marks, where we just have to calculate the price of two bonds, one for corporate investors and one for retail investors. The most frustrating thing is that they don't tell us the interest rate that we'll use, but they do tell us that there's a zero coupon government bond, which has a nominal value of 1,000, a price of 500, and is 10 years long. So we're going to use that. Present value of the outgo will be the price we pay, 500. Present value of the income will be the 1,000 rupees we get back in 10 years. So that gives us v to the 10 is a half, and solving that gives us I is about 7.177%. Okay, let's deal with the corporate bondholders first of all. Let's get their tax rates. We have income tax of 20%, so T1 is 0.2. Capital gains tax of 10%, so T2 is 0.1. We're told that the coupons are paid quarterly, so P, the number of payments per year, are 4. And the nominal value is 100,000 rupees. Now, since the coupon rate is 6% per annum, that means the annual coupons will be 6,000 rupees. And the redemption is 105% of the nominal value, so our redemption value will be 105,000. Okay, now since we've got capital gains tax, the first thing we need to do is carry out a capital gains test. We'll calculate I4 at our rate of 7.177%, which gives us 0.06992. Do store this on your calculator, you'll need this value later. And we calculate the net coupon rate, which is 0.0457. Since I4 is greater than this, this means we have a capital gain. Okay, so let's work out the price. Now the price will be the present value of the future payments. So we'll need the present value of the net coupons. So we'll keep 80% of them after income tax. Then we'll get the full redemption, and then we'll take off the 10% capital gains tax on the capital gain, which is the difference between the redemption value of 105,000 and the price we pay. And capital gains tax is paid at the end. All we have to do is rearrange this equation. So getting the p's on one side, we'll have 1 minus 0.1 v10 p's. Simplifying the right-hand side, we'll have 4,800 A10 and 94,500 v10. Now certainly we can use the fact that v10 is a half to save a bit of time, but we'll also need to use the value of I4 on the denominator of the annuity. Calculating this gives us a price of 85,869 rupees per 100,000 rupee nominal. Okay, let's now do the same thing, but for the retail investors. So the income tax is 15%, capital gains tax is again 10%, coupons are still paid quarterly, We're working a nominal of 1,000. Coupons are still 6%, so 6% of 1,000 is 60, but it's redeemed at par, so we'll get 1,000 back. We need to carry out the capital gains test. I4 is still the same as before, but the net coupons are now 0.051. Again, we can see that the interest rate we require is greater than the net coupons, so once again we have a capital gain. Setting up a similar equation of value, we have our net coupons plus our redemption minus our capital gains tax on the capital gain when we redeem it. Taking all the p's onto one side and simplifying what's left on the right hand side gives us the following, and solving this for p gives us 857.59 rupees per £1,000 nominal. A very easy 15 marks to finish with. Hopefully you didn't run out of time. We hope you found this exam review useful. We provide coaching for Indian students via our online classroom. On screen now is a link to a YouTube video of a sample unit from our CT1 classroom. If you like what you see, then feel free to visit our website for our Indian students, www.acted.co.uk/India. Thanks for watching.